Hey again, everybody. Just real quick, wanted to take a video to go through Bridge with you guys, just in case we didn't make it through while I was still in the room. Looking at question number one, it's trying to get you to identify which substance is an electrolyte. And most important, clearly, is the word electrolyte. And if you remember, that means it's going to conduct electricity and it has to dissolve in water to form mobile ions. So what we're looking for in our answer choices is one thing that can be broken apart into two ions that exist either on the periodic table or on table E. And just looking at our answer options, the two that stick out immediately as not plausible at all are answer choices 2 and 3. Those are very clearly completely covalent things with no distinguishable ions. They're just sugar-like molecules that aren't going to be able to break up into anything that we see on table E. Looking at 1 and 4, you can see that OH is kind of lingering on both of them, and we may not be sure which way to go. So we can try and break these apart in a couple of different ways and see which one makes the most sense. If we look at the first one, I could try breaking it here, which would make an OH minus and a C2H5 plus. But if you look on table E, C2H5 plus just doesn't exist, so that doesn't work. Even if I break it after the O and make it H plus instead, you don't even have a negative ion that makes sense, because that's not on table E either. No matter how you try and break option number 1 apart, you're just not getting anything that's going to dissolve to form those mobile ions according to table F and the ions listed on table E. So that leaves us with choice number 4, and hopefully there's a way to break it apart so we can get those ions we need. And breaking it at the OH isn't going to get you there, because CH3CO plus isn't on table E. But CH3COO minus sure is. That's the acetate ion, and it, when combined with H plus, makes acetic acid. So this is actually a common acid, and as you guys know, all acids are electrolytes. So answer choice number 4 makes the most sense based on the requirements of being an electrolyte itself. If you take a look at question number 2, we're looking at a mixture of two different substances, potassium nitrate, so that's ionic, and chloroform, which, if we draw its structure out, Cl, 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 and an H, looks like a polar covalent molecule to me. We add those two things to water and stir it around until everything's all dissolved. We know this thing is going to dissolve completely, and this is polar, so it should also dissolve based on the like dissolved like principle. So if everything's all dissolved, it should be all mixed nice and evenly. So I'm immediately, without thinking, going to eliminate answer choices number 3 and 4, because it sure can't be heterogeneous if everything has dissolved completely. If it's homogeneous, that means we've got a liquid that we can't see any visible difference in. There's no chunks, there's no layers, and there's certainly nothing that can be caught by a filter. Remember, think of a filter just as like coffee paper. The only thing that's going to stay behind on a coffee filter is coffee grounds, something solid. There's no chunks or lumps at the bottom of this homogeneous solution, otherwise it wouldn't be homogeneous. So answer choice number 1 is the only one that makes sense. Answer choice number 1 does not make sense. Just kidding, folks. Answer choice number 2 is the only one that makes sense, because if it's homogeneous, it can't be separated by filtration. So answer choice number 2 makes the most sense here. If you move on to question number 3, now we're talking hexane in water. And you didn't necessarily mix these two yesterday in lab, but if you take a look in the fume hood in the back, you're going to see a greenish yellowish liquid. And if you hold that up, you're going to see that there are two very distinct layers. One kind of clear thing floating on the top, and the greenish yellowish layer down on the bottom. This kind of models this scenario. The greenish yellowish color is coming from some food coloring that dissolved in the water. So these two things have separated into two very clearly distinct layers, because hexane, which is our 6 carbons, 1, 2, 3, 4, 5, 6, connected by all single bonds and surrounded by hydrogens, That's a very non-polar molecule. And as I'm sure you have ingrained in your mind now, water is a polar molecule. So because there's no reason for those two things to be attracted to one another, they don't have those positive negative interactions that polar molecules enjoy. Because they have different molecular polarities, they're not going to mix. And that's why we see layers in things like hexane in water, or more commonly, something like oil in water is probably something you're familiar with. We can use that same train of thought to address problem number 4. So explaining in terms of molecular polarity. So in your answer, somewhere you're going to say it's polar or it's nonpolar. Why rubbing alcohol, or 2-propanol, which is shown here, is soluble in water. Well, if it's soluble in water, that means it's able to dissolve. And because like dissolves like, polar stuff should dissolve in polar water. And sure enough, if we look at this, yeah, we've got a sort of line of symmetry down here, but going across, this OH does not match up with this H. So this is a polar molecule. So because of like dissolves like, this polar substance will easily dissolve in water. So because 2-propanol or rubbing alcohol is polar, it will be soluble in water, also polar. And that way we're addressing the molecular polarity of both the solvent and the solute. So at this point, if you have any questions on bridge, please stop the video. I'm going to make a different one for mini lesson and go over any questions you might have with Miss Poulton.